Today we'll discuss about one problem which was appeared in CSIR-NET in 2016, and the booklet code is A and the number is 51. And here the question is like that. Consider a circular orbit in the central force potential, and this potential is given like this form, and where the k is a positive constant and the n number lies between 0 to 2. And if the time period for the circular orbit is r, then the time period is t1, and if radius is 2r, then the time period is t2. Then we have to find out this ratio between time period t2 by t1. Okay, and here also we will follow the same procedure. So the four steps to solve any physics problem, that we have to find out what is the given data. So the given data is here, the form of the potential, which is something like that, and the k is a positive constant and n lies from 0 to 2, and the time period when our radius is r, the time period is t1. When the radius is 2r, time period is t2. Okay, and what we have to find out, our aim is to find out t2 by t1 ratio. Okay, that means we have to find the t2 and t1 and then divide it. Then we have to find out the ratio between t2 and t1. Now the third step is generally we use to find out what is the formula and what is the concept. Here in the third step, so we want to find out what is the concept behind this problem. So we know that the concept is here very simple. The potential, if you there is a relation between the potential and the force is the negative derivative of the potential. So here this will be minus of d by dr of k minus k by r to the power n, which is actually n, n k r to the power n plus 1. Okay, this is the force, but as we know that here this particles moves in a circular orbit, that means this force obviously the centripetal force, and we know the centripetal force is like something that mv square by r, if the r is the radius of the orbit. Okay, and now this force is exactly equal to this force, that means this is exactly equal to the force, centripetal force, and here we take the magnitude only, so you can take it as r to the power n plus 1, because here we have taken this r as the capital R, the radius. Okay, but we know that there is a relation between the linear velocity and angular velocity, which is actually v is equal to r times omega. So we can here put it here. So v r square omega square by r, which is n k r to the power n plus 1. Now take simplify this one. So r will be cancel out. So this will be m r omega square is equal to n k r to the power n plus 1. Okay, so I keep this omega square in one side and take all the constant, all other terms to other side. So this will be n k r to the power n plus 1, and we know the n and k both are constant, so we can write this equation as omega square is proportional to the 1 by r to the power n plus 1. Okay, but we know that omega is actually 2 pi by t, so we can write it as 4 pi square by t square proportional to 1 over r to the power n plus 1, sorry, r to the power here, r to the power n plus 2, actually this is n plus 2, this is n plus 2. Okay, so that if you take the 4 pi square, which is also another constant in this side, so it becomes 1 by t square is proportional to 1 over r to the power n plus 2, or simply you can write that t square is proportional to the r to the power n plus 2, or which is we can write as t is proportional to r to the power 1 plus n by 2. Okay, now in the question it is given that when the radius is r, the time period is t1, when the radius is 2r, time period is t2. So t2 will be 2r to the power 1 plus n by 2, and t1 will be proportional to the r to the power 1 plus n by 2. So if I take the ratio, the both this proportionality constant will be cancel out. So this will be T2 by T1 will be 2R divided by R to the power 1 plus n by 2, which is nothing but 2 to the power 1 plus n by 2. Now the T2 by T1 ratio coming out, which is R1 T2 to the power 1 plus n by 2. Now go to the option, and here the third option is the correct option. This is actually exactly matching with our answer. So the third option is the correct option.